So let's discuss the CLIP algorithm. So CLIP algorithm is an dual encoder architecture that is solving a problem which a traditional image classifier cannot solve. That is, in suppose we have 100 millions of images with a specific 100 classes. So we the trained model can only identify within within the 100 classes, but the clip algorithm expands this limitation and by taking the caption of each and every image. So potentially it can identify n number of images that it has trained on, not limited to specific classes. So it uses a dual encoder architecture to solve the problem. Dual encoder architecture, one encoder is for converting the image description that that serves as an annotation of the image, that converts it into embedding, and the second encoder converts the image into a embedding, and both the encoder uses shares the vector space so that the embeddings can be directly compared using cosine similarity. So this approach was an intelligent move by OpenAI so that images can be compared against text, because to collect the data from various sources is a very very difficult task. So OpenAI scrapped the internet to get the image text pairs and compare them directly using the model, using the clip algorithm model, and this was named as contrastive learning on images pre-trained. Contrastive learning images on pre-trained. So why this approach is suitable? Uh, because images and text are encoded independently, so that they can be stored in a database, and whenever a user searches or queries a database, we can get the most relevant top images using the query. So this was the main benefit of using the clip algorithm, but it also has some trade-offs, such as the caption may not be fully representing the image and can introduce randomness. For an example, a ideal caption should be snow-covered Himalayan mountains under a clear blue sky, right? So where the model can capture the relationships from the text and can map it to the image, such as snow covered is the white mountain regions, mountains are large rocky structures, Himalayans a particular mountain range, and blue sky is a visual background feature. But there but that can be incorrect caption also, that can introduce randomness, such as a beautiful view from my Himalayan vacation. So it doesn't provide the model much useful relationships and introduces noise, increases the noise in the model. So if we have many such examples, model will capture noise rather than the true patterns, and so the model can fail to get the relevant images using the query. Therefore, there can also be many such image text pairs. So let us look at how it does the image and text comparison. It takes the image. What is this here? It takes a image text pair and tries to maximize the similarity of the correct image text pair, and 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 tries to maximize the distance between incorrect pairs. So The similar text pairs should be closer in space and the incorrect pairs should be farther in the vector space. That's how a clip model is trained, and we can query them using a text instead of a traditional method by giving an input to the image, or yeah, giving an input to the image. Thank you.